This is a story about challenges.
A story about competition.
A story about technology.
A story about teamwork.
A story about triumphs and setbacks.
A story about exploration.
A story about the past and future. I'm Molly McKinney.
I'm Caleb Kinchlow.
And this is NASA 360.
This story starts with a rock. Now, pretty much anywhere you go in the solar system, from the furthest asteroids and comets to nearby planets and moons, chances are you can find a rock. Now, this may not look like much, but don't let that fool you. These rocks, whether found in your backyard or on Mars, can teach us some extraordinary things. I'm here with planetary geologist Dr. Bill Moore.
Most people know about rocks probably that they're hard. You find them out in the desert. You can see lots of layers when you see them out there. Maybe something they don't know about rocks is that pretty much the entire planet they're standing on is made of rocks.
So why do you think it's important for us to study rocks?
Well, rocks are kind of like the Earth's history book. The rocks have been around recording Earth's history for billions of years.
Do you think we can learn the same type of information from other planets with the rocks?
Absolutely. Just like the rocks on the Earth, rocks on other planets also record the history of those planets. They record when things were molten and when lava flowed and when mountains were built and when cracks were formed and when craters happened. So the geologic history of every planet is recorded in its rocks.
Generally speaking, how do we get these rocks?
At present, the only ones we know about for sure are the rocks that the astronauts picked up from the moon and the pieces of Mars that we have identified here on the surface of the Earth. They were blasted off the surface of Mars, flew through space, and actually re-entered the Earth's atmosphere and crashed here on Earth. We have several pieces of Mars. Those are really the only pieces of any other planet that we think we have. We have lots of pieces of asteroids. That's what most meteorites are from.
And what's the best way for us to get these rocks?
The best way is when we can be right there where the rocks are. We can understand how the rocks are related to the rest of the planet's surface, when we can pick up a rock and see where it came from, actually visit Mars and be able to see where the rocks came from on the surface.
So are rovers and spacecraft the best way to study rocks?
Well, they're the best way we have right now. We can study the rocks from orbit. We can see where the mountains are, where the volcanoes are. With our rovers, we can get up close and personal with the rocks. We can zap them and prod them and look at their chemical compositions.
So is that as good as it gets?
Well, no, actually. As great as the rovers are, we could do much better sorts of analyses here on the Earth. And it's important for any sort of geological question to understand what the context is, where the rocks came from. And so we would love to be able to analyze these rocks with the kinds of powerful machines we have here on Earth that we just can't miniaturize and put on a rover.
So what do we have to do to get those rocks here?
Well, we need to obviously go there, have some sort of machinery to pick them up and analyze where they came from so we know, and then bring them all the way back home safely and intact. The rocks we've been trying to study on Mars, for example, we've had to study remotely. Our rovers who have been able to take pictures and make measurements and poke and prod and look at a few rocks up close, but they haven't been able to actually send any rocks back to us. They've just been able to send back a little bit of information about those rocks.
So this rock holds tons of information about our planet. But in order to get the same information from other planets, we have to do some exploring.
And I'm here with someone who knows a lot about exploring distant places, Chris Ferguson. Chris, you've spent more than 40 days in space. You were the commander of the final space shuttle mission. Now, even though NASA's shuttle program has come to an end, one could argue that their role in exploration is getting even more exciting.
Absolutely, Molly. As we finished up the shuttle program, there were a lot of people to thank. And I remember a few of the speeches that we had made in a part of thanking all those people, and one of them was that, we're not really concluding a book here, we're just closing a chapter of a book that will never end. And we do. The space program lives on. Today we're working with a lot of commercial companies to get commercial transportation from the Earth up to the International Space Station and to other destinations. Of course, we have missions to Mars. We're still looking at the history, the geological history of that planet, the evidence that water might be there.
Now, in terms of exploring distant places, one thing we can usually bank on finding are rocks, rock samples. What have we done in the past? How have we gone about acquiring these?
Well, of course, one of the biggest tasks we had while we were on the moon was to bring back a lot of rocks. I think we brought back over 700 pounds of rocks. And the interesting thing is, even though we brought them back many, many decades ago, we're still learning new and interesting things about the geological makeup of the moon. And can you imagine when we get the first Martian rocks back, what that's going to be like? We have probes and rovers on Mars right now that are able to actually probe the rocks. But boy, wouldn't it be interesting to be able to hold one in your hand and tell the history of a planet just by the constituent of the rock that you hold. So it's an amazing future. And of course, astronauts, they always have geology training. The early astronauts learned all about the lunar surface through the geology training that they did out in New Mexico. And even the astronauts of today still go on a geology field trip.
Well, of course, learning about these distant places is going to be challenging.
When you go to a foreign planet, when you go to some place else, and you have to learn how to work and operate on a place that no one has ever been before, how do you do that? I think what you're going to see is that robots are going to work alongside humans. Humans will be the eyes and the ears and the brain behind the operation, but we're going to put a robot out there where the environment is hazardous, there's a lot of radiation. For example, on the outside of the International Space Station, we have the capability to put Robonaut. Robonaut launched on a space shuttle a couple of years ago. He has the ability to kind of climb all over the space station and be the eyes and the ears of the astronaut on the inside so that the astronaut can remain safe and secure while the Robonaut does the dangerous things on the outside, like changing a box or fixing a filter. So, I mean, it's incredible what we're doing with robotics today, and I can only see the future getting brighter.
One thing's for sure, going to other worlds, finding a sample and bringing it home is going to be a difficult challenge. And NASA knows a thing or two about challenges.
You can't think about NASA without thinking innovation. Since its inception, NASA has been pushing the envelope in technological advancements, landing astronauts on the moon to helping build and operate an international orbiting space laboratory. And of course, the countless NASA spinoffs that you probably use every day. In fact, NASA has an entire office devoted to technological advancements, and they call it the Office of the Chief Technologist.
And I'm here with NASA's Chief Technologist, Mason Peck. Mason, you have to forgive me. I don't know exactly what a Chief Technologist does.
Well, a number of things, but most important is to guide and coordinate all of NASA's technology investments. So deciding which direction we're going to invest in for the future.
Would you agree that now it's maybe even more important than it was in the past to really push the advancement of technology?
Absolutely. It's essential for NASA's future. New technology is what makes it possible for humans to explore asteroids or Mars, which is in NASA's future, and for robots to do that as well. All these technologies are going to enable the next generation of exploration, whether it's through human activity or through robotic activity. We're also looking at not just technologies, but new ways to work with companies, small and large companies, to bring that future to the present. It's about innovation in technology, but also new ways that we can solve those problems. Remember, it's only through technology investment that the Apollo program, landing humans on the moon, was even possible. And what we're investing in now is going to enable the next generation of missions. We can also incentivize new technologies by offering prizes through competitions. We can bring in some new ideas, very fresh ideas. And sometimes it's ideas that aren't just motivated by money. I mean, there are these prizes that motivate these things, but people who compete in these prize competitions, they put a lot of their own resources toward it. So it's a way for NASA to get new ideas. Also, we don't pay until we actually get the results. So we're sure of getting some great results out of this.
So tell me about some of the successes that have come out of these prize competitions.
There's a lot of great stories. One of them is rocket companies who were competing to launch and then land. Those companies have now started their own product lines. Companies who are now going to be able to provide rides or launches for NASA thanks to that competition.
So give me an overview of some of these challenges.
Well, we have the Centennial Challenges program at NASA. This has been around since 2005, and over that time it's offered $6 million in prizes. We've had 15 competitors out of 100 actually be awarded those prizes, and it's ranged from aeronautics prizes for aviation all the way through space challenges, including robots and launch vehicles. So it spans a huge range of activities relevant to NASA and also relevant to the nation, because these technologies can be built on and provide products and services that actually matter to all Americans.
So, Centennial Challenges have led the way for innovation in green aircraft technology, astronaut gloves, and power beaming, just to name a few. Wonder what challenge NASA has in store for us next? Find out when we return.
Prize competitions like NASA's Centennial Challenges aren't a new thing. In fact, Charles Lindbergh's solo flight across the Atlantic was inspired by a prize challenge. And these challenges continue to this day. Now, NASA has a new challenge. And trust me, this one is no walk in the park.
I'm here in Worcester, Massachusetts at WPI, which stands for Worcester Polytechnic Institute. And today they're holding what's called NASA's Sample Return Robot Challenge. And it is so exciting. As you can see, it's more than just a competition, it's like a festival.
Curious about robots? So were thousands of people of all ages who have come to WPI today to see the competition and celebrate science, technology, and engineering. But the main event is, of course, the sample return robot Centennial Challenge. And that's why I caught up with Sam Ortega to get the scoop.
So the Sample Return Robot Challenge that we're conducting today, it's all about advancing autonomous robots. NASA is looking to be able to develop a robot that we can send to Mars, to an asteroid, to another planet, that will be able to go off and do its research, do its collection, do its data sampling without any human interaction. So we want to be able to let it go off and just do it by itself.
The grand prize of this is $1.5 million if the robots can compete both phases of the competition. That's a lot of money. What is NASA getting out of this?
It is a lot of money, and so what NASA wants to get out of it is the technology and the sensing controls for the autonomous robots, for them to be able to use that in some of our future programs to go explore other planets or asteroids. You know, the other neat thing about this challenge is it's more than just what NASA's going to get from it. For the competitors themselves, we're hoping that they can go off and take this technology and go up and do something else, either start a company or expand their own small company they may have and use that technology in another field or another way.
So speaking of teams, who can compete in this competition?
What we're looking for at Centennial Challenges is we want to advance the opportunities for citizen inventors, for small companies, medium-sized companies. We want to give them the opportunity to take advantage of the technology they have, the smarts that they have, layer them up and come up with an innovative solution to a problem that NASA might have or help solve the problem for the nation itself.
So Sam, if you could paint a picture of what a successful challenge would look like today, what would it look like?
For me, as the program manager, a successful challenge is any time we have the opportunity to advance the technology. So whether we have teams win and be able to advance forward to compete for the 1.5 million, or whether we just have teams come back and say, wow, we think we understand a lot better how we can make our robot, how we can make this technology work better, work for us. So no matter what happens today, we're going to get there. I think we're going to see a lot of advancement in the understanding of sensing, of autonomous robotic control, even between the teams themselves. They're already,
Even in a collaborative sense where they're going, oh, that's
you got
so
it.
cool. I never even thought to do that.
And you already see that with some of the teams as they're unpacking the robots. They're looking, oh man, we should have done that.
Why didn't we think of this?
Exactly. Yeah. I don't necessarily want to make sure that we give the money away. I just want to make sure we advance the technology.
I have to say, I think it's incredibly brave of these people to travel from all over the world, compete in a very public competition where people can be nitpicking and critiquing every move of the robots. I'm excited to go meet these competitors.
We are now entering what is called the pit. And this has really been home base for these teams here competing. This is where they can fine-tune their robots. They can really perfect and work diligently on the sensing capabilities, which is going to be, as we know, a difficult challenge in this competition. So let's go back and see who we can meet. What makes this robot different from some of the other ones we'll see today?
It has 3 wheels.
Yes, a tripod. That's touche. So what makes this robot different than some of the other ones that we'll see during this competition?
It's the smallest one.
Really?
Yes.
Little guy wins,
Yeah,
right?
this is the little guy, the runt. I was wondering if anyone else would go that route, but that is one of the unique features.
Why did you choose to go that route?
It's fewer wheels to make.
Tell me about your robot.
His name is Cerberus because he has 3 heads, one looking forward, back, and up. So he could guard the gates of Hades if he wanted to.
We got multiple rovers with our scout rovers and our collection rover.
And you're doing this all by yourself?
This is it. My wife's on the team, but it's pretty much built by me.
Probably because she has to be, because this is all you spend your time on. She would never see you if she didn't help, right?
Yeah. We drove here from Southern California, so my wife drove the van for 5 days while I sat in the passenger seat writing code with this guy in the back.
So how difficult is it to get all 3 of these playing nicely together?
Very difficult. We're actually still working on all the code.
Hardware I have confidence in. The problem is, and this is a problem with everybody, is it takes so long to build the robot that there's no time to write the software.
We take for granted the way our brains control our bodies, but to get that primitive brain to control this body is a really fantastic challenge, and that's fun when you get it to work a little bit almost right. Then it's really exciting.
I keep thinking of the song "If I Only Had a Brain" from The Wizard of Oz, because that's where my robot is right now. It's just and it needs a brain, but the thing is I have to type in the brain.
Right, you have to use your brain to program a brain.
There isn't a lot of time to do that.
So is there anything you can do about the software at this point, or what's your plan?
I mean, get a bigger whip to crack on the software guys. There's nothing to do.
Are you feeding them? Do they have caffeine? Are you doing everything you can? Tell me the story of how you and Chris linked up.
Chris and I met back in 2001 doing SECR, which is Southeastern Combat Robotics. We were competitors. We fought a lot. Actually, I beat him the first time, so you probably don't want me to say that.
Were you one of those kids that took toys apart and drove mom crazy?
Oh, yeah. And probably Dad.
You didn't introduce me to this team member of yours.
This is actually Marvin the Martian. I'm sure most of you guys know childhood days.
I took more than toys apart.
What else?
Phones and appliances and valuable things like that.
Everybody kind of relates my personality to Marvin the Martian, you know, as far as being out there and just being crazy and doing all this stuff. So when I turned 18, my first tattoo actually was Marvin the Martian.
So aside from the time commitment, I'm sure there's the financial commitment as well.
Yeah, this is all from my retirement account. All from my money saved. No sponsors.
No wonder your wife is involved in
She's
this
like,
then.
Yeah.
How?
I actually left my full-time job just to work on this. So this has been my career for the last year.
And how have you been funding it?
Savings.
Let's go back to your childhood for a second. I had heard that you wanted to be an astronaut growing up. Is that right?
I didn't.
No, so what does it mean being able to compete in a competition of this magnitude?
This is kind of like a dream come true, you know, being a part of NASA, being here with you guys.
Sure, I'd like to win, but I like to do it just for doing it.
It's a hobby.
It's what I like to do anyway, so.
If we actually win some prize money in this, then I don't know how I'm going to react.
As you can imagine, nerves are a little high right now. Stay tuned, you won't want to miss this. When we come back, the action really picks up.
Three, 2, 1, go!
And they're off. Each of the robots has to complete specific objectives, completely autonomously. That means no driver, no remote controls, nothing. These robots are working completely on their own.
Now, just because the robots are moving around on their own doesn't mean that they're artificially intelligent. There is a lot of engineering and programming involved before each rover can complete this challenge. The teams have specific guidelines and ground rules to get them started. Let's tag up with some people who can explain just how challenging this competition really is.
Okay, Ken, so walk me through what's happening on the field right now.
This is the first stage of this challenge. This is the level 1 competition going on right now.
In level 1, the teams have 15 minutes to go out and they want to try and find a pre-cached sample, pick it up, bring it back to the platform. Now, if they do that successfully, they get the opportunity to go on to the next level. And during that, they have 2 hours to navigate this huge course which has 10 samples on it.
This is fully autonomous. You know, you push one button, the robot's computer has to come on gracefully. It has to not go blue screen on you. It has to actually boot up. And then it has to find out what direction it's pointing. There's no compasses there. And so it looks for landmarks. It turns on its computers. Most of them have more than one computer. You have to synchronize these computers. And so it can take several minutes of nothing obvious, but a lot of energy being used trying to figure out where it is. And then it takes off in what it thinks is the right direction. It's trying to avoid obstacles. If it stops, it's because it's reevaluating things. It's trying to get a picture of where it is, but doing it accurately and being able to navigate to a known location without the use of any earthbound aids is incredibly tough. And it's not just getting there. They have to now then manipulate a very difficult to grasp item and bring it back, all the way back to the home base within 15 minutes. It's a tough job, really tough. No one's ever really done this sort of stuff before.
So let's talk a little bit about what contestants knew once they got into this challenge when they were preparing for it versus some of the hidden surprises that could still be lying in the course.
So they were given rules to the challenge that highlight everything that their robot is allowed to do, the weight restrictions, the size restrictions, the information about the samples, and anything else that's critical in terms of the game. So, you know, our idea is not to surprise them with anything, but to really to learn more about autonomous navigation technology and to help them advance the state of the art in autonomous navigation.
So how does judging work? Will there be judges?
There are judges who are here. They're here to enforce the rules. They're not, you know, necessarily judging who's got the prettiest robot and who's got the best engineering, as much as they're here to make sure that all the teams have met all the rules.
Now, what safety protocols have you built into this competition for both the robots' safety and for the people that are judging?
We have a follower that stays in a cone of invisibility behind the robot, so it doesn't affect its navigation, but it has to have a pause switch that they can push, and the robot has to stop all action within 1 second. That's really tough, by the way, and some of our competitors are really struggling with that. But the pause is a safety feature, so when a pause happens, the time stops and the judges come rushing out there, they look at it. Sometimes they'll actually even call the owner of the robot to say, this is happening, do you want us to continue on or not?
Yeah, if it reacts, if you have to pause it again, go ahead and e-stop, and we'll hard stop and we'll be done.
And it's designed to be tough, it is.
It's designed to be real world scenario.
Yeah, exactly, and that's what we expect to see out there.
The robots came and competed, the teams did their best. Let's regroup with Sam and hear his thoughts on how this competition went. All right, Sam, so the Centennial Challenge is over. What are your thoughts looking back on it?
You know, I think it's been really good. We had a lot of teams come out, they were able to compete, they were able to run the robots. Unfortunately, we didn't have anybody go pick up the sample for the level 1 competition, and because they didn't pick up the sample, they're not able to go to the level 2 competition for the $1.5 million. But I think we've advanced the technology a lot. I think the teams are really set and they're pretty excited about what can happen next.
So Sam, moving forward for this Centennial Challenge, what is everybody getting out of this?
You know, when people go to compete, we've discovered, talking to a lot of our teams, there's really 3 things that motivate them. It's guts, glory, and bucks. So the guts part is, they're here, that's a challenge, and they're gonna meet the challenge. And the glory part is, they wanna win, they wanna succeed. And then there's the bucks part. Of course they wanna win the prize money. Everybody wants to do that. They've completed the competition for today. We didn't have anybody pick up the first sample. So they're gonna go back and they're gonna start focusing on the guts and the glory. They wanna advance this technology. They wanna be successful. So they'll go off and start tinkering with their bots and figure out what went wrong and try to correct it and see if they can't keep going further to advance the technology itself.
So would you consider this event a success then?
It was a great success on all parts because we were estimating maybe about 2,000 people within the local community to come and watch this competition. We actually ended up having over 6,000 people coming. We had people coming from New Hampshire, we had people coming from Pennsylvania. So with our Science and Robotics Festival on campus at WPI, and with the competition as well for the teams themselves and for the public to be able to talk to the teams and talk to them directly, these people are competing and creating these technologies. They got to actually interact with them and talk to them. That was a great success for us.
Sam, what were some of the biggest surprises looking back on this challenge?
I think the thing that really surprised me the most was the tenacity of the teams. And even then that wasn't really a surprise. I expected the teams to come ready to compete. But one of the teams, Space Pride, they were getting ready, they were doing some last minute work on their bot the night before the competition. And it was gonna go to impound at 8 o'clock at night. 7:50, smoke starts coming out of the robot. That's never a good sign when you have smoke coming out of your electronics. And they didn't give up. They didn't throw their hands up and just say, that's it. They started talking to each other and they're working at it, they're figuring out what was going on. They ended up clipping some wires, crimping off some wire, and they got it still operational and got the smoke to stop coming out and things worked great.
Wow, what an amazing experience it has been here at WPI at NASA's Sample Return Robot Challenge. Caleb, it has been so cool seeing these robots compete.
It sure has, Molly. And just think, we are a few steps closer to bringing something like this from somewhere out there. Until then, NASA and people like the competitors in the Centennial Challenges will continue to push the limits on technologies that will expand our horizons and bring the mysteries of our universe a little bit closer to home. For Molly McKinney, I'm Caleb Kinchlow, and this is NASA 360.